This question is asking us to find the force P due to the vertical force at D of 900 newtons. And we're also asked to find the reaction of point A due to the force of P. So to start with, we can write out for part A, we can write that the sum of moments about the point A is equal to 0. And that's going to look like this. So it's going to be d of y times the length AD minus P times the length AH is equal to 0. So we're going to solve for this unknown value P. Since we can find our lengths AD, lengths AH, and we already know what d of y is. So we're going to start solving for the unknown lengths in our free body diagram. So first we're going to find the length BG, and that's going to be equal to 200 times the sine of 60, which will be equal to 173.2 millimeters. For length AG, that's going to be equal to 200 times the cosine of 60, and that will give us a length of 100 millimeters. For length GD, that's going to be BG over the tangent of 70 degrees, and that will be equal to 63.04 millimeters. And next we'll find length AD. And from the free body diagram, we can see that length AD is going to be equal to length AG plus length GD. So that's going to be 100 plus 63.04, which will be equal to 163.04 millimeters. And next we'll find the length AH, which will be equal to the length AG plus the length BC times the cosine of 15, which will be equal to 486.4 millimeters. And we can now solve using this equation for the moment about A. So we can say that 900 times the length of 163.04 minus force P times 486.4 is equal to 0. And taking this expression and solving for P, we get a value of P is equal to 302 newtons. And that completes part A. Now for part B, we're going to find the reaction. We're going to find the reaction at this point of A. This point of A due to the input force of P. So to start with, we can write out that the sum of moments at the point D will be equal to 0 after that point at D has been lifted up. We can assume that it will be in equilibrium. So we can say sum of all moments at D is equal to 0. And that's going to look like this expression. So it's going to be A of y, the y component of the reaction, times the length AD, minus the force P, times the length dH is equal to 0. So we plug in what we know, and we solve for A of y. So that's going to look like A of y times 163.04. So 163.04 minus 302 times 400. So to get the length dH, we do 486.4 minus 163.04. Set that equal to 0. And we solve for the unknown variable A of y, the y component of the reaction. And that will give us a value of negative 598.96 newtons. And we now solve for the x component of the reaction. So for the x component of the reaction, we can write out the following expression. So the sum of moments about B is equal to 0. And the expression is going to look, using the terms from the free body diagram, we can write negative P times G of H, length GH, plus the x component of the reaction times BG plus the force 600 times AG. And we set that equal to 0. So we plug in the terms that we know. So we have negative 302 times 400 times the cosine of 15 plus the x component of the reaction times 173.2 plus 600 times 100, and we set that equal to 0. And we solve for the x component of the reaction, which will give us a value of 327.3 newtons. And we can also solve for the magnitude of the reaction. By taking the square root of both components squared and added together. So we have the x component squared plus the y component squared. And that will give us a reaction of 682.5 newtons. And to solve for the angle of this reaction, which we'll call theta, we take the tangent inverse of the y component over the x component. So the y component divided by the x component, and that will give us an angle 61.38 degrees. And that now completes part B.